So, hello everybody and welcome to this talk. It's about Angular and performance tuning. And first of all, let me introduce myself. I am Manfred and I'm a trainer and consultant focusing on Angular. And I'm also part of the Google Developer Expert team. That means that I have a direct connection to Google, that I can ask questions and that I'm getting answers. I have also written a book, it's in German. It's the book with the most ugly cover animal, but anyway, I'm very proud of it. It's also about Angular. So I would suggest let's start with a picture. Who knows this machine? Yeah, it's a Intel 386, the hero of my childhood. And the most awesome thing about this machine was this button here. There was a turbo button. When you pressed it, the machine was about twice as fast as before. Okay, the original purpose of it was to make the machine slower by pressing it again, to be more compatible with older versions of the machine. But anyway, it was just a matter of pushing a button to make it faster. And so the question arises, is there something for Angular? And the answer is, yeah, there is. There are some quick wins you can use with Angular to get faster performance immediately. And one of those quick wins is bundling, putting all the JavaScript files into a tiny amount of files. Another quick win is minification, to get rid of long names, to get rid of commands, to get rid of long variable names and white spaces. And a third thing is the production mode of Angular. You can put Angular into production mode and then Angular will be much faster. Of course, the error messages won't be that nice, but Angular will be faster. And the good information about this is that the Angular CLI is doing all this for you. You just have to do a production build with the Angular CLI and you get all this for free. But in addition to that, there are also some things you can do in addition to that to make the Angular application even faster, and this is what this talk is about. In this talk, I will talk about lazy loading and preloading. I will talk about performance boosting for data binding with onPush, and I will also talk about AOT, ahead of time compilation, and tree shaking. But first things first, let's talk about lazy loading. So, by the way, a good friend of mine told me that I'm very authentic when I'm talking about lazy things. I'm not sure what he meant, but I think it was some kind of compliment. Doesn't matter. So what you see here is the typical structure of an Angular application. The typical module structure contains an app module, it contains several feature modules, and it contains one or several shared modules. And as you see here, the app module is also referred to as the root module sometimes. And normally, everything is loaded at startup. And of course, that means that your startup performance is influenced in a bad way. And this is exactly where lazy loading comes in. Because with lazy loading, you just need to load one module when you start. Of course, you can load several modules at start, but at minimum, you can just go with one module. And each other module is just loaded on demand. When the user clicks here or there, the other modules are loaded via the network into the memory, into the browser. And of course, this is influencing startup performance in a very, very good way. So what does it take to get started with lazy loading? The answer here is get started with lazy loading is very easy. It just takes one special root that is using load children, as you see here, one special root that is pointing to the module in question, to the lazy module. And for this, you have to mention the name of the module. In this very case, the name of the module is flight-booking point module, and you have to mention the module class. Each module is represented by a class in Angular, and this class name has to be appended after a hash. In this case, the class name is also flight booking module in Pascal case. when you are triggering this route, Angular will start to lazy load this module, and then of course the question arises, which route is activated within this module? And the answer is, this lazy module can have an own routing configuration, and of course this routing configuration can have a default route. And this is the route without a path, or let's say with an empty path, like here. And in this case, this very route is activated. So when our module is lazy loaded, the flight booking component, which you see here, gets activated at the screen. Of course, you can directly jump to a subroute within a lazy module. For this, you have to trigger the route that is triggering lazy loading. In my case, the route has the name flight booking. This is the route that is leveraging load children. And then you have to abandon the name of the subroute, which is subroute in this very case. So let's have a look at an example for this. Here I have prepared a tiny sample application. It's about booking flights. And you can switch to flight booking. Flight booking is lazily loaded, and there you can search for flight and also book for flights. When we have a look at the configuration, we are seeing this lazy route here. We are seeing that flight booking is triggering lazy loading of this module. And when we look at the network tab in our browser, and when we reload the application, then we see that everything is loaded, everything but not our module that has the name flight booking. But when I'm clicking on flight booking, then we see that this flight booking module is just loaded on demand. So we see that here the flight booking module chunks enters the browser. Nice thing, and of course, this is influencing the startup time in a good way. But it also comes with a drawback. Let's reload everything again. And let's click on flight booking, which is triggering lazy loading. Did you see this loading indicator? Let's do this one more time. Yeah, there was this loading indicator, and of course, the loading indicator didn't show up for a long time because I'm testing with localhost, and localhost is a very fast network connection. But when you are going with 3G, fast 3G, slow 3G, or something else, this loading indicator would take a bit longer. So what does this show? This shows that lazy loading is just postponing work. It isn't making the work going away. It just means that you have to do this work later. And because of this, this leads to a slightly delay during the execution of the application when the user is clicking here or there. And this is exactly where the next topic comes in. And this next topic is preloading. So the idea of preloading is pretty simple. The idea of preloading is that modules that might be needed later are loaded after the application started. So first of all, the application starts. That means that the user sees something very quickly. And after this, after the user saw the first screen, the application starts with lazy loading in the background. And because of this, the module is available immediately when we need it, when the user clicks here or there. What does it take to go with preloading? We just need to register a preloading strategy when we are setting up our main routes. To set up the main routing table, we are normally using for_route. Router module for_route. We are passing in our array with the routing configuration. This array is called RouteConfig here. And then we can pass in a parameter object. And as part of this parameter object, we can define, for instance, a preloading strategy. In this very case, I'm going with the preload all modules strategy. It is a baked-in strategy. it comes with Angular, and as the name implies, it just preloads all the lazy modules after the application started. Of course, you can also write your own preloading strategies. For instance, preloading strategies that are just preloading things the current user is allowed to use or the current user will use more often than other things. So I think it's quite easy to get started with this and to use the best things of both worlds, the best things of going with and without lazy loading. So much for this. Let's switch to another topic that can improve your performance. Let's talk about performance tuning with on-push. And instead of talking about theory, I will just jump into my example one more time and show you a motivation for on-push. So, as mentioned before, within my example, I can search for flights. Let's click at search. And there is also this delay button, which is delaying just the first flight. Not the other ones, just the first one. Just have a look at the first flight. You see 11:57 here, and after pressing delay, it's 12:12, and then it's 12:27, and then it's 12:42. I think this is what Lufthansa is doing all the time. But when you are looking at the second and the third flight, you are seeing that nothing changes when I'm pressing delay. For instance, just have a look at the second flight. There is 13:57, and when I'm pressing delay, it stays at 13:57. So, as mentioned, just the first flight is delayed. Perhaps you've noticed the blink effect here. So this isn't a talk about animations. I'm not the right guy for animations. But in this case, I want to visualize the change tracker of Angular. I'm using a very dirty hack here to visualize the work of the change tracker. Every time Angular is checking a component for a change, these components are blinking. And here we see that even though just the first flight is delayed, Angular checks all the flights. This is the default behavior of Angular. And normally, this is done in a very fast way. Angular is even generating code for this to make this procedure very, very fast. But sometimes this isn't fast enough, especially when you are triggering events in a short time. A lot of events in a very short time, for instance, by triggering a lot of mouse move or mouse over events, then this could cause a performance impact. And the solution for this is on-push, the on-push optimization technique. So when it comes to on-push, you can just tell Angular that it shouldn't check some components at all. For instance, you could tell Angular that it shouldn't check your flight cards, or that it just should check it when it gets notified about a change. So of course, now the question is, how can we notify Angular that just the first flight card has been changed? And the answer is there are several possibilities for this. First of all, you could change bounds data. Data that is passed to the component by the means of a property binding, by the means of an input binding. But this isn't as easy as it seems, because Angular is just checking whether the object reference has changed. In on-push mode, Angular is just comparing the object references. It is just doing a check like this here. It checks whether the old object is the same object as the new object, whether the former flight is the same flight as the current flight. And when this holds true, Angular assumes that nothing has changed. If this isn't true, Angular is looking at the component and Angular is trying to find out what changed within the component. To put it in another way, this means you aren't allowed to just modify a property. You aren't allowed to set the date property to a new value. You have to create a whole new flight object, and you have to set the whole new flight object to the new time and to the other properties of the old flight object. This is what they are calling immutables. Immutables are quite usual in the area of functional programming. They aren't that usual in the area of object-oriented programming, but nevertheless, as mentioned here, they can, of course, improve the performance because the framework just needs to check one object reference. There are other possibilities for notifying Angular about changes. For instance, you can raise an event. You can raise an event within the component in question. And a special case of this is you can notify a bound observable. When you bind an observable to the template, and when this observable comes up with a new value, Angular will check this very component. And of course, you can trigger change detection manually. But please don't try this at home. It isn't a good idea to do change detection manually. In this case, you are bypassing the framework, and bypassing your main framework is a bad idea in most cases. I would say try hard to avoid this. Perhaps there are some events where you can't avoid this, but I found out in general you can avoid this by leveraging one of the first 3 approaches here on this slide. To enter this on push mode, you just have to set this change detection strategy on push. And as you see here, you can do this on a component basis. That means you don't have to use on push with all components. You can just decide which component needs more performance, and then you can turn it on. Of course, there are also people out there who are using on push all the time. People who want to have the best performance all the time. Here I have a diagram that shows how on push works when you are changing the inputs. In this example, I'm passing flights down to my flight card. And in this case, when I'm using on push, Angular just checks whether the object reference changed. And when this is the case, Angular will have a closer look to the component in question. If this isn't the case, Angular will just skip this component and all its subcomponents for change tracking. Here I have another example. Here I'm using an observable. It is called flights dollar or flights dollar. And I'm binding this observable to a template using the async pipe. And one more time, in this case, Angular will trigger change detection when this observable comes up with a new value. Let's have a look at another demonstration for this. Here in this demonstration, I will just leverage on push. The good message about this is that my delay button is already creating new flights. Every time I'm pressing delay, a new first flight is created, and it gets all the data of the former first flight and the new date. And because of this, I can easily switch over to on push. Let me just do this. For this, I will put the microphone away. Okay, as you saw here, I'm just activated on push for this very flight card component. Let's switch back to my example. Let's search for a flight. Let's delay my flight, and hooray, you see, Angular is just focusing on the one and only changed component. And of course, we all can imagine that this has a lot of potential for performance boosting. Okay, so much for this. Let's switch to another topic about performance tuning. Let's talk about AOT, ahead of time compilation. Perhaps you know it. When you are going with Angular, your HTML templates are compiled to JavaScript code. And this is because JavaScript code can be evaluated more easily in a faster way compared to HTML code. And in addition to that, the engine, your browser engine, can optimize execution of JavaScript. It is very good at optimizing execution of JavaScript code that must be executed several times. And this is the case when it comes to evaluating templates. This is done all the times when you are going with Angular. And for this compilation, there are two approaches. One approach is the just-in-time approach. Just-in-time means that compilation takes happen at runtime when the application starts. And one more time, this leads to a bad startup performance. And there is another approach, an approach that will be the default approach with Angular 5. At least there are plans for this. It is called AOD, ahead of time. That means that we are compiling the templates during the build process. And there are some advantages of AOD. Of course, the first advantage is very obvious. The first advantage is we get a better startup performance because Angular does not need to do compilation during the startup phase. But in addition to that, there are also some not those obvious advantages. For instance, a non-obvious advantage is that we end up with smaller bundles. The reason for this is we don't need to include the compiler in our bundles. We don't need the compiler at runtime at all, so we can skip the compiler. We just need it at build time. Another advantage of this is that tools can easier analyze the source code, because everything consists out of JavaScript, and because of this, the tools we are using can analyze the JavaScript code, the whole code, and try to find out which parts of frameworks aren't needed. And I'm sure when you are using libraries or frameworks, you are never using all the parts of them. You are just using some specific parts of them. And leveraging a technique called tree shaking, we can hunt down those unneeded parts and just remove those parts of Angular or of other frameworks from our bundles. Tree shaking is a nice metaphor for just shaking the source tree to make all the loose branches fall down. When I've talked about this about a year ago, then I showed the audience how to configure the Angular compiler, how to set up the Angular compiler and how to make it work with your bundling and tree shaking solutions. Nowadays, we can just leverage the Angular CLI. We can just do a production build with Angular, and when we are doing so, we just get ahead of time compilation. We also get tree shaking. Behind the scenes, the Angular CLI is using this plugin here. It is called the AOD plugin, and it's located within the ngTools Webpack package. As the name implies, this is a plugin for Webpack, and the good message is you can use it even without the CLI. When you have a direct Webpack configuration, you can use it with it. Soon we will get a new plugin for this purpose. It is planned for Angular 5. I've seen the release notes today in the morning. It seems like it will really get into Angular 5, and it's called the Angular Compiler plugin. You don't have to worry about this when you are using the CLI. When you are using Webpack, then you can just use it. 1 minute left. No, I don't believe this. Oh, okay, so I have to speed up. So this can be used with the CLI too. So let me give you just one demonstration, and then we are finished. In this last demonstration, I've prepared 2 builds of my application. The first build is a production build that isn't leveraging AOD. Let me just start this production build. And when we now switch to the performance tab of our browser, when we clear the cache and when we reload everything, then we see that the startup time was about 1.5 seconds. So when you repeat this with an AOD build, just to save some time, I have prepared this on a slide, we end up with about the half. And I think that shows the potential of AOD. That shows that AOD can really cut your start performance or your start time to the half. Okay, so much for this. Let me just make a conclusion as we are running out of time. As we have seen at the start of the presentation, there are some quick wins. You can leverage bundling, minification, and the production mode. And the good message is the CLI does this for you. In addition to that, we have seen that you can improve the startup performance with lazy loading and preloading. We have also seen that there is something like on push you can use to improve your data binding performance. And you have seen in my last demonstration that we can leverage AOD and tree shaking to shrink our bundles and to make the startup performance much better, to cut it in the half. To the half. Okay, today I have also a workshop about this. Perhaps we are meeting at this workshop. It's about at 1 p.m. And here I have my contact data. You find all my material and slides, and you can also write me an email when you have a question. So thank you for this and have a good time at the conference.